Okay, first off, you'll notice that I'm showing the Java code in Android Studio. I will explain how I was able to import the Cocos2d-x project into Android Studio in a separate video. For now, I would just like to focus on the code. I will start off with the Android manifest. Although there isn't really much to see here, the only change you really need to make is this use permission to record the audio. You need this permission, otherwise you cannot use the microphone. Now, I should point out that if you want any decent performance at all for recording audio, you must use multi-threading. So right here, I've created a separate thread just to handle the recording, which I called recorder thread. It's a new class. I have two volatile booleans here, running and suspended. I use these to determine whether the thread should run or not, or whether it should stop executing. This is so that the thread isn't taking up valuable resources while you have the app minimized or closed or such. In here we set up our our formatting for when we start recording. And we also need a buffer to store our data. Sound data is byte data, of course, so we have an array of bytes here. And because we are using 16-bit encoding, it is an array of 2048 bytes. You can see here, though, you don't want to just assume that. It may differ depending on hardware. So the first thing you want to do when you create this thread is to get the minimum buffer size. And we see that we pass in our sample rate, our channels, and our audio encoding. Then we want to make a new recorder. And again, we pass in the same information as well as our buffer size and the fact that we want to record from the mic. And then we create our buffer. Here we have is recording. First, we want to make sure the thread is alive and that our recorder is currently in the recording state. Now, getting sound and interpreting it is normally more complicated. However, for the purposes of this project, all I needed was the amplitude of the sound wave. So all I have is this get volume here. So if we are recording, then we want to read bytes from the microphone, and it'll read the appropriate amount for the buffer size and put it in the buffer. And then we calculate the average amplitude along the entire length of the buffer. So this is what this for loop is doing. It's adding the amplitudes together, which it grabs it in groups of two. It takes the entirety of the first part plus an 8 left bit shift of the next slot. And then we get the absolute value of that and store it in here. And then once we've done that, we average the value, and that is our average amplitude. If we're not recording, then of course there is no amplitude, so we return 0. And here, this is where the thread runs. While it's running, we have this try block here because this is where it could be suspended, and suspension could be interrupted, so you want to put this in a try-catch block involving the interrupted exception. So if we are suspended, we want to synchronize this block of code so that when we are told to resume, we are able to catch that message. It's not easy to catch that message if you don't synchronize it. It may send at the wrong time, then your thing will suspend forever. So the synchronization is important. And then while we're suspended, we want to wait. And I'll show how to resume later. But here, assuming we're still running, then we want to get the volume, or amplitude as I mentioned. If the amplitude is not the same as last time, then we want to store this new volume, and we want to send it to the application. And I use a listener setup for this, which I'll show in a moment. And here we have start and stop recording. If we started, then we're not suspended. This will start the recording. And then if we're stopping the recording, then we want to suspend the thread because we're not really doing anything with it. And then once the application's over, we want to make sure to release the resources of the recorder. So we do that, then we say we're not running anymore. And here's the listener setup. I'll show the interface in a moment. But first, the class that is implementing the listener has to pass in itself to set that it's going to listen for the volume change. And then when it does, it sets the listener onto this class. And then when we experience a volume change, if we have a listener, then we tell that listener that the volume has changed and pass in the new value. And here you can see the listener's very simple. It's just this onVolume change. And then here in the actual app activity, I'll just start with onVolume change first. First, we have run on UI thread, because before we were running in the recorder thread, now we want to make sure that the data we're passing goes back to the main thread. So we do this run on UI thread, and then we have a new runnable inside, as you can see here. We call our native function sendVolume, and this passes the new volume to the C++ code. Now let's go back to the top. There's not much import. It's just the Cocos2d-x activity and the bundle for onCreate. As I mentioned, we implement onVolume change listener. We have a recorder thread as well as the native call. It needs to be static, so that since it's a static call, here we have onCreate. We set up the new thread, we start it, and then we set the onVolume change listener as I mentioned. Now, if we are pausing, then we want to make sure that the thread is not running, as I mentioned. So we stop recording, and then when we go up to resume, we want to start the recording again and make sure the thread starts over again. So, as I mentioned, we want to be synchronized with the thread, then we notify the thread that it should start running again. And then when we're finished, we want to release the microphone resources, so that's what onDestroy is for. That is all the Java code. In the next part, I will get to the meat of the game by showing the C++ code.